Hello and welcome. My name is Omar Hani. I will be explaining the least common multiple or LCM. Least common multiple belongs to the transform and conquer strategy. The transform and conquer is usually used when the given problem is too complicated or is there a simpler way for it to be solved. It consists of three techniques: instance simplification, problem reduction, and representation change. We'll only be talking about problem reduction. Problem reduction, the idea behind the technique is to transform the given problem into another one that's easier to solve. You can do it by using an existing algorithm that you already know and modifying it to be applied to the given problem. What is the LCM and what is the GCD? The LCM is the smallest number that is divisible by the two given numbers. For example, LCM of 4 and 6, you will find all the multiples of 4, all the multiples of 6, and you will get the smallest common multiple. The GCD is similar, but we're looking for the greatest number that is the divisor of the two given numbers. For example, the GCD of 54 and 24, we'll find all the possible multiplications that can give us 54 and all the ones that can give us 24. Then we find the greatest of the common ones. Now, the GCD algorithm, or its code, it works by something called an Euclid's algorithm. It works by, as the pseudocode says, as long as b is not equal to 0, we'll keep moving, the while it will keep operating, and works by putting the number b in a temporary place, and then we get b will becomes a modulus b, and then a will become equal to that temporary. Okay, we'll keep going until b is equal to 0, and then we'll return a. Let's say I have a room or a rectangle and I need to know what is the smallest size square that I can fit inside. Well, we'll go about it like this. First, I'll make the biggest square I can make, which in this case will be a 15 times 15 square. And then the only place I have left now will be a 5 times 5 square. A better example will be here. As you can see, now we will know that the smallest size square that I can use to fill this big rectangle will be a 5 times 5 square. Now to understand how the GCD works and Euclid's algorithm, we'll go to the relation between the LCM and GCD and how it can help us solve the LCM. So we know that the relation between them is that the product of the LCM of two numbers and the GCD of the two numbers will equals to the product of the two numbers absolute. So in order to get the LCM, we'll turn the equation into the LCM of a and b equals the absolute of a multiply b over the GCD of the two numbers. So how we'll translate this into a code? First, we'll get the GCD, and then after we get it, we will using the GCD what they had, which is x, will be a times b over x, and which should be 60. I'll show you the code running. Now this is the code I will show you. Now after we run it, we have the GCD, which is 5, and the LCM would be 60. As we have said before, we take the GCD from here, and then we use it in order to calculate this e times b over the GCD, which is x. Now, the analysis. For simplicity's sake, we'll assume that a is bigger than b. Therefore, a modulus b will always be smaller than a over 2. We'll as well assume that both a and b are being halved and that they are powers of 2 for the sake of simplicity. Now, our initializing statement will be as follows. T of a and b will be smaller than or equal to t of a over 2 and b over 2 plus t. And our base case of t of a and 1 will equal to 1. Now, we will keep going. T of a over 2 over 2 or a over 4 and b over 2 over 2 or b over 4 plus 2 times 2, and the same with the next one, a over 4 over 2 or a over 8 and b over 4 over 2 or b over 8 plus 2 times 3. We will change it to make it look simpler. Will be a over 2 over 3 and b over 2 over 3 plus 2 times 3. Now we can notice a pattern slightly, so we'll generalize it as much as possible. A over 2 bar k and b over 2 bar k plus 2 times k. Now we need to reach the base case, so we will assume that k equals log b, so b over 2 bar k will equals 1. From here we know that base case of t and 1 is 1, so it will be 1 plus 2 times log b, and now LCM algorithm belongs to big O of log b. Thank you.